Hello guys. All right, in this video I'll be talking about the physical significance of this psi. The psi that's a wave function that's called as wave function, a wave vector, or a wave amplitude. And this psi is a complex physical quantity. And this psi cannot be directly measured. There cannot be any means by virtue of which we can directly measure this psi, this wave function, this wave vector. But the dynamical variables that are associated with this moving particle, like the position, momentum, kinetic energy, potential energy, these dynamical variables can be evaluated from this wave function psi. If we have to understand that this psi is a complex function, and if I choose a complex number for this psi as a plus iota b, so as said earlier, that this psi cannot be directly measured. It doesn't have the physical significance at all. But if I take the complex conjugate of this psi, that's called psi star, that complex conjugate will be a minus iota b, where a and b can be attributed as real functions. Now, if I multiply this psi with psi star, so psi star, what will be the result will be a plus iota b into a minus iota b. So on evaluating this expression, what you will get rid of this iota. This iota is under root of minus 1. So iota square is minus 1. So you can evaluate this and you will find this psi. You can find this psi star. This psi star will come out to be a square plus b square. So it can be visualized here, at least as a means of argument, that this product of psi and its complex conjugate leads to a result which is real in nature, right? And this product of psi with psi star is called as probability density. We call it probability density. Psi star. It's written as like this, psi. Now this is called as probability. It's called as probability density. So, measuring this probability density can take us to the probabilities, not the classical probabilities, can take us to the quantum probabilities of locating a material particle which is moving under the influence of these de Broglie matter waves. And in turn, the other dynamic variables that are associated with this particle can be evaluated. Now, this representation of psi star is also called as Born interpretation of wave function. Born interpretation of psi. So this is what I was trying to reveal.